So this next experiment or setup is again with the Arduino Mega 2560 microcontroller. This one is going to be utilizing what is known as an ultrasonic sensor module. How an ultrasonic sensor module works is one of these ends on here emits a sound, an ultrasonic sound, and the other one detects it. And the two working in conjunction are able to triangulate a distance, I believe using Pythagoras' theorem, to calculate how far away an object is from the actual sensors. The information is then loaded into the microcontroller, and from the microcontroller it's going to be displayed on this liquid crystal display module. And there is a 10,000 ohm potentiometer that is going to be used to control the display brightness of the LCD module. The ultrasonic sensor is actually, I believe, would be quite useful in building an autonomous robot. Imagine you wanted a robot to move along the floor and to avoid objects or obstacles, specifically a wall. You could program the robot so that if the distance between the sensor and the wall was, say, 100 centimeters, then go ahead and keep traveling. But if you came within, say, 10 centimeters, to stop and adjust itself so that it would avoid colliding with the wall. This particular setup is going to be reading the distance in centimeters. And I've set up this table so that the sensor I'll have to hold with my hand will be resting at 0 centimeters. And I'm going to be placing objects at 15, 25, and 30 centimeters away. And we'll just see how accurate the sensors is. And I'm just going to put down a ruler. It's hard to see with the light, I apologize, but there is roughly 0 centimeters. There's roughly 15, 25 and 30 centimeters. So the Arduino isn't powered on, but I'm going to pause and then power it up and we'll see the results. So I have the Arduino Mega 2560 powered up, and the appropriate sketch for detecting the distance between the sensor and an object is loaded into the microcontroller. I'll get an angle so that you can see. It says distance 2154 C. Now that means 2154 centimeters. I'm just going to put my hand in front of the sensor. You can see it drop down to 10 centimeters. My hand is right there. 6, 7, 5. But what I'm going to be doing is I'm going to be placing this sensor at the 0 mark that I've measured out. And over here is a box at 30 centimeters. And let's see how accurate the sensor is. There we go, distance 30, oops, I moved my sensor, sorry. 30 centimeters. 29, 30. So I guess there is a little degree of uncertainty. So when you were programming a robot for avoidance collision, you would want to make sure that you take into account like a plus minus. So say, for example, if you wanted to make sure you were exactly, or if you wanted to make sure that it didn't come any closer than, say, 5 centimeters, then you might want to program it so that it would react at 8 centimeters. Now I'm just going to move this to the 25 centimeter mark. And we'll go back and put this at 0. And there you go, it's 24 centimeters plus or minus. And now I'm just going to move it to 15. And now it's saying 14 centimeters plus or minus. One thing too is a little mistake that I made initially is the sensor, I was actually holding it there and I couldn't figure out why it would be off. And that's because the actual sensor itself is not at 0. You want to move it back. And then you'll get a proper reading.